Hey guys, today I'll be explaining a 45, 45, 90 degree triangle. This is another type of special right triangle, and in my previous video I talked about a 30, 60, 90 triangle. And both of these are special right triangles, and both of these are really helpful because you don't have to use any of the trig functions like sine, cosine, tangent, and the other ones to solve for the side lengths using the angle measures. Instead, you know the fixed ratios, and you can just solve using proportions and ratios. So here, these values 45, 45, 90 represent the angles of the triangle, and the angles are 45, 45, and 90 because it's the right triangle. And because 45 and 45 are both equivalent, that means this side and this side would both be equivalent. And the ratios for all three sides are x, x, and x root 2. So like I said before, since these are both 45, that's the reason why both of these sides are equivalent. And you can also look at it like this, whereas it is 1, 1, and root 2, because this is 45 and 45. And using these side length ratios, if you're given one side length, you can solve for the other side lengths. But you have to know that this is a 45, 45, 90. And if you're given all three side lengths, but you're not given any of the angles, you can figure out whether it's a 45, 45, 90 triangle or just a normal or some other type of right triangle. So we'll start out here. You're given one of the legs. And since you know that this is going to be x and this is x2, you know this is 4. And since you know this is x root 2, you know this is 4 root 2. So that's really easy. And same thing applies here. Since you know that's 3, you know this is 3 because this has to be x. And since you know it's x root 2 up here, you know this is 3 root 2. However, it can be tough sometimes when you only are given the hypotenuse. So say for example, you're given a hypotenuse of 8. Now you have to solve for these other side lengths. So what you do is you first of all divide this by root 2. So you do 8 divided by root 2, multiplied by root 2 up top and the denominator. You get 8 root 2 over 2. And that is 4 root 2 when simplified. So you know this is 4 root 2 now, and you know this is 4 root 2. So even though this might be a little bit more difficult, it's still the same process. And another situation I'm going to show to you is when you're given all three sides, but you have to figure out whether it's a 45, 45, 90. So if you're given a hypotenuse of 6, and you're given a, if you're given two leg side lengths of 3 root 2 and 3 root 2. So first of all, what you would do here is you divide the hypotenuse by root 2 to see if you get the same x value for both of these legs. So I would do 6 divided by root 2. Multiply root 2 up top, multiply by root 2 down here. And you get 6 root 2 over 2, which gets you 3 root 2. So since both of these are 3 root 2, 3 root 2, you're able to understand this is a 45, 45, 90 degree triangle. So that's it for the 45, 45, 90 degree triangle video. So this is also one, like I said before, this is also one of the special right triangles, and the other type of special right triangle is 30, 60, 90. And these are really helpful when it comes to solving for the side lengths using the angles. And that's it for this video. So I hope you guys subscribe and like it, and I hope to see you in my next video.